Hello everyone, my name is Rohit Singhal and we were discussing about the topic redox reactions. In the previous lectures, I have discussed briefly about what is redox reaction. It is nothing but the combination of two things, reduction and oxidation. Initially, we separately deal what is oxidation reaction and what is reduction reaction. We have given the definitions of these in terms of removal of hydrogen or electropositive and electronegative atoms. Further, we discussed that every reaction has a basis of electron transfer thing. So, we discussed these redox reactions also on the basis of electron transfer. But we have discussed that whenever an element is losing electrons, it is said to be oxidized, whether or whereas when an element gains electron, it is known as been reducing reaction. So, also one thing we discussed that reduction reaction and oxidation reaction can't go individually, they go well with each other. Means if something is getting oxidized, there will be something another element that will be reduced. Later on we discussed another two things called oxidizing agent and reducing agent. What we told ki for a molecule to get oxidized, it need to lose electrons, and for it to lose electrons, there should be someone to gain electrons, that is acceptor of electrons, and that acceptor of electrons is known as what? The oxidizing agents, and donor of electrons is known as reducing agent. Then we discussed about whether the comparison or the comparative electron transfer thing. So, let us discuss in deep about that thing. So, what we were discussing was competitive electron transfer reactions. What does it mean? We have seen an example, you have done in earlier classes in class 10th, this experiment you might have done, that when you take a copper sulphate solution, in water, it is blue in color. Okay. But as soon as you dip a zinc rod, a metallic zinc rod into the solution of copper sulphate, what happens is that slowly and slowly this solution, the blue color, or let us say, let us paint it as blue. This is a blue color solution, and this blue color solution, on adding the zinc rod into the copper sulphate solution, this blue color disappears, and what you see is a brown color complex get deposited on the metallic rod. This brown color compound or element, let us say, it is actually not compound. So, let us say element gets deposited. So, now this is the experiment you have done in the earlier classes. Now, we will discuss what the actual reaction is going behind this reaction. What happens is, when you add a metallic zinc rod in the copper sulphate solution, the copper sulphate solution, what happens is this zinc converts into Zn2 plus, this zinc goes to Zn2 plus, and this copper 2 plus goes to copper. So, what is happening is Zn is losing 2 electrons, Zn is losing 2 electrons, that means it is getting oxidized, and this copper 2 plus is gaining 2 electrons, and it is getting, that means it is getting reduced. Okay. So, now the thing is, why this blue color disappears? Because this blue color solution was due to the presence of copper sulphate, copper 2 plus ions. Now, in this solution no more copper 2 plus ions are present. no more copper 2 plus. Why? Because this copper 2 plus has been converted to copper by gaining 2 electrons, and this copper, this elemental copper is brown in color, which gets deposited on the metallic zinc rod. That is why the metallic zinc rod gets brown in color, whereas the solution, that is because of the presence of copper 2 plus ions, the blue color disappears because there is no more presence of copper 2 plus ions, as they have been converted into copper, which has been deposited on the metallic rod of zinc. So, now this is one of the reactions. Now, let us see another reaction where we do the opposite thing. Let us say what I am doing, I am using a zinc sulphate solution and I am inserting a metallic rod of copper. I am taking a zinc sulphate solution and I am inserting a copper rod. Now, what happens is no change in color, no color appears, no color disappears, no change in color. That means no reaction is happening here, no reaction. Now, we have one thing in mind, that here this copper 0 does not go to copper 2 plus. That means, whenever there is a presence of zinc and copper, so zinc preferentially goes into Zn2 plus, whereas copper wants to into the copper 2 plus, but the copper state. That means, the reaction that I have written earlier, is not a an irreversible reaction, not a reversible reaction. That means, this right hand side product favors now. Why it is so? If we insert a zinc rod into the copper sulphate solution, it gets oxidized into zinc 2 plus, whereas the same case opposite we are doing, but copper is not oxidizing into copper 2 plus. Now, let us see another example, and then I will discuss why it is happening so. So, let us take a copper sulphate, again a copper rod in an, let us say a silver nitrate solution, or let us say silver nitrate solution this is. So, we have to deal only with the cations here. So, I am just using the cations. So, what I am doing is a silver nitrate solution, and using a copper rod into this. Now, you remember in the case of zinc sulphate, the copper was not oxidizing into copper 2 plus, whereas in this case this copper gets oxidized to copper 2 plus and silver gets reduced to Ag. That means, there if you balance out the electrons, so this will be like this. It means, gain of 2 electrons, and here it is loss of 2 electrons. Now, what this thing suggests us, that zinc preferentially wants to go into what? The Zn2 plus oxidation state. It means that zinc is more prone to the oxidation as compared to copper, and copper is more prone to oxidation as compared to silver. So, this we have concluded so far. This means preferentially goes in, or we can say oxidation of zinc is preferred over copper and silver. That means, what we are saying, that in case of zinc, copper and silver, zinc is the element that wants to go into the process oxidation state, then after copper and then after silver. This is nothing but in science, on chemistry, we call it as electrochemical series. What we call it? Electrochemical series or metal activity series. What? Metal reactivity series. What this electrochemical series tells us is the electrochemical series tells us that which element is more prone to oxidation, which is more prone to reduction. That means, it gives a series of the different metals that which will go to the oxidation first and which will get the reduced first. This we will discuss later in the higher classes about the entire electrochemical series, but now you are just getting a brief idea about what is electrochemical series, and zinc is more preferentially oxidized in presence of copper and silver. So, this we have discussed so far about the electrochemical series. In the next classes, we will discuss about the things that is oxidation number, oxidation state. A new concept will come, that is oxidation number, oxidation state. Then we will discuss about the types of redox reactions. We will discuss about the let us say balancing, how we can balance this redox reaction, because if you see this previous equation, you see this copper, I am just balance out this 2 from 2 here, okay, just because to balance out the number of electrons, because the gain of electrons should be equal to the loss of electrons. I am saying the gain of electron should be equal to loss of electrons, or I am saying number of gain of electrons to the number of loss of electrons. This should always be keep in mind that the gain of electron, number of gain of electron should be equal to the number of loss of electrons. Okay. So, the next topic we will discuss in this thing is oxidation number. What this oxidation number is and why we need this thing is oxidation number. Now, you have seen in the previous cases where I have discussed about the charge, about the redox reaction on the basis of electron transfer. So, where I have discussed this Na plus and Cl minus, this positive and this minus, okay, this Na reacting with Cl2 gives Na plus Cl minus, and then I have told you the sodium 0 to going to plus 1 oxidation, plus 1 charge. But let us say if I am doing this CH4, I am using this CH4, I can't say this C is plus 4 or H is 4 minus, this I can't say, because this is not an ionic compound. This is not an ionic compound. We know we can write these charges in terms of only the case of ionic compound, but this CH4 is a covalent compound, and covalent compound is formed by sharing of electrons, and not the transfer of electrons. Now, in case of ionic compounds, it is too easy for us to whether determine that the charge is getting added or it is getting reduced. But in case of covalent compound, we do not know what the actual charge on any element in a compound is. I do not know, C does not exist at C4 plus cation, right. So, this is now a problem for us, and we want to solve it, at how we can now in terms of, in case of covalent compounds, how we can measure this, that how the charge is getting transferred, means whether the charge is getting increased or decreased. So, for that there comes a concept called oxidation number. This oxidation number, if I will discuss, let us say an example, H2 plus Cl2 gives HCl. This I have discussed, this is plus 1 minus 1, this is because an ionic compound. But let us say if I am discussing H2 plus O2 gives 2H2O. Okay. This is easy for us, we can say this has been the, we can say addition of oxygen So, this addition of oxygen means what? Oxidation reaction. And this O2 to H2O is what? Addition of hydrogen. And this is okay. Now, though we can see a bit that is H2 we can say is a 0 oxidation state, so sorry 0 charge you can say, not oxidation state. Let us first introduce what is charge. We can say it is 0 and this H is we can say what +2 -2 +1 -2. So, this is again H2 is in a covalent compound. So, there is been an ambiguity whether to assign the charges on this covalent molecule. So, for that we have assigned this oxidation number. What oxidation number is? What oxidation number is? This oxidation number has been developed for what? It assumes that there have been a that means what oxidation number is a more practical way of assigning these charges to the covalent compounds, so that we can know whether the molecule is getting oxidized or reduced. It's this oxidation number assumes that there has been complete electron transfer from what? An electron transfer will happen from what? From a more electronegative atom, from a more electronegative atom to a okay. That means what oxidation number assumes that there has been a complete transfer of electron from a more electronegative atom to a less electronegative atom. Okay. Oh sorry, I have written out the opposite thing, from a less electronegative, that means from a electropositive atom, from a less electronegative atom to a more electronegative atom. As the same case of the ionic compounds, let us say I am saying this H and oxygen, you know oxygen is more electronegative element, right. This is more electronegative. Now, if you see the more electronegative atom will gain electrons or lose electron, it will gain electron. So, there will be a transfer of electron from hydrogen to oxygen, transfer of electron. This is a more electropositive element, this is a more electropositive. This hydrogen is more electropositive and oxygen is more electronegative, and there has been transfer of electron from a more electropositive element, or let us say less electronegative element to a more electronegative element. So, we will see that there has been a complete transfer of electrons rather than the sharing. Just this is an assumption, this does not happen, there is been sharing of electron between hydrogen and oxygen, we are just assuming. So, for our simplicity that there has been a complete electron transfer from hydrogen to oxygen, or a less electronegative atom to a more electronegative atom. This oxidation number we will in later classes discuss in detail to what oxidation number, how we can find out for different molecules. We do some examples that we will do in the later classes. Thank you.